Okay, so it's recording. So I wanted
Okay.
today to implement the stack manipulation actually,
What
because
about before we even do this, what about we write a simple to do?
sure,
Oh, I am not sharing here right now on
yeah,
Emacs.
you're only
See,
sharing the Xcode.
can I open a?
You probably can open a text file there.
Can you guys see this window? I think now you can, right?
Yes, I can see the
So let's
title.
type features. So the first feature would be what?
Um, well, which one you want you which part you want to start? You want to start with the beloved and very delightful parsing, or you want
No,
to implement first?
absolutely not.
Or you want to implement first the stack operations, for instance,
So
the
let's. Uh, I mean, this is more recurrent task, right? We will be
no,
changing
no, no,
this
but the
consistently.
paper separates them in like categories. You have flow control, we have stack operations, we have load
Oh, okay.
store.
Okay. So what he calls stack operations are like pop, dupe, that kind of stuff.
Yeah, he
Okay.
actually calls
Yeah.
them stack manipulations if we want to be pedantic.
Okay.
So we have a push, a pop, which we're gonna use those names. We're not gonna use his names.
Why
Uh,
not?
Oh, what are the names he uses? I didn't read.
he uses like uh, a, like the value, and then greater than together without spaces. This is a push.
Oh, that's
No,
like
that's actually
that's flow,
means
right?
putting the top of the stack into the index register, which is a different thing.
That's not what is written here. What is written
Which
is the page 70 on the PDF. It's saying mnemonic a greater than, the name is a from, operation put a onto data stack.
Just one thing. Look at
yeah,
how awesome it is. The slogan.
A runtime
yeah,
at your
because
service.
you see, Lemos, the A is actually the name of a register, which is used as an index for loops. Like there's a dedicated register for that. And then any kind of data manipulation is actually done on the stack. That's kind of the point of a stack machine.
No, no, no. We're not disagreeing on that. I'm just disagreeing that the mnemonic should be this.
No, it has to be because there's also the B register, and there are also operations to move values between the return stack and the data stack, and they have similar names to the A greater than.
Well, maybe we're gonna have to
The
use
greater
weird
than is
names.
actually, yeah, the
Oh,
greater than is actually
let's do
meant
the
to be
following. We
read
will
as an
decide
arrow.
in a bit.
Yeah, sure. We're gonna decide later. But Marin may be
What
right.
else?
Maybe this has the greater than has actually a
Yeah, we'll
greater meaning.
see. I don't know. I don't know what you guys because I didn't read the
Okay,
paper,
so the
so I
next
don't know.
there's also a category called arithmetic and logic,
Right.
which is like not, and, plus. Uh,
I suspect we also have to do some sort of address management.
yeah, probably that is on the load, the store, and literal fetch. So yeah, yeah. So the ones that interacts with the memory, load, store, and literal fetch. And then there's another category down there called no op and undefined.
So
Uh,
neutral instructions.
yeah, I think we can call it like that for now. And they literally
The
do nothing
undefined,
actually.
yeah, the undefined is actually because the architecture in the paper doesn't use the full range of possible opcodes or 5 bits.
Oh, by the way, send me the link of the paper. I'll put
It,
here.
it is in the Discord Chime chat. It's actually pinned there.
Let me see.
But
Oh,
I should have
Chime.
read more about it though, because I didn't pay attention about I didn't look too deep into the architecture. Because now that I think about it, we are actually implementing a computer, if you think about it. So we should
Oh,
actually think about
simulating
that.
one.
Uh,
Okay. So
so
neutral
there isn't
instructions.
only a stack, Mageta. You know what I mean?
Oh, what we were saying in the beginning. You mean?
No, no, no. Yeah, kind of like that. But now that I think about it, we're gonna have to have in our things registers to put values in there
No,
and
no, okay. Man, I just want like a path for the next five
no, that's
sessions or
that's
so. We
fine.
don't
That's
need
fine.
to. I'm pretty sure we're gonna end up with like a dozen features. So I think this is a good start. We can keep adding
No,
more.
that's fine. But I didn't think about that. We need to model the computer that this is
So
gonna
today
run.
we're gonna do this.
Yeah, I want to do that.
Okay, perfect.
Yeah,
So
speaking of registers, just a quick aside. Uh, the paper is called Second Generation Stack Computers, right? And it
Yeah.
actually computer architecture, sorry, but it actually does give a definition that tells you how to like to tell apart the first generation from the second one. And the difference is the second generation stack architecture, it uses registers to implement the stack. So they exist inside of the processor, not in the main memory.
Wait, what lives in the processor?
The stacks, they are implemented as registers inside the processor, not as not as soft stacks, let's say, in the main memory, which is what the first
Ah,
generation did,
okay, I see.
and
I
what C
understand.
machines still do actually.
I understand
C
that.
machines, I mean, register machines. They put
Okay.
the stack. Yeah.
I think we should
Anyway,
start with stack manipulations. The first thing, Maget, we should go to our. We should make another class called Chime Computer. Actually, we should have that.
uh, first of all, let's just review very quickly what we
Sure.
have.
Yeah, this is actually
So
the first session on YouTube actually, so it's
yeah,
fair.
that we record, yes. So basically, just started this. By the way, we have Nix. Uh, we just need to update. I don't know if it's working because I'm on macOS.
Yeah, he's on
Uh,
macOS.
but we have this monstrosity here that should work on Linux. So anyway, on
I mean,
NixOS.
it's Objective C, so it kind of makes sense that he's on macOS for this.
Yeah, like I said, no man. Like I already have everything on Apple. Why would I? Why would I have to use a GNU step? So anyway, but there might be incompatibilities, right? If you try to run it on Linux.
Yeah, I'm
Okay,
gonna discover
so
that running myself later.
Objective C is very weird because it's like C with more stuff based on Smalltalk, and but still has like pointers and all the jazz. So you can write perfectly equal code to C, as far as I know. Uh, but you can also like do some uh, kind of stuff that it would be only uh, possible in like C++. Not only possible, that's incorrect to say, but
It would
I
be
was
more at
looking at
least
the
expected to see in
pointers.
C++, right?
Yeah, I'm more expected to see in C++, but I think it is more safe than C++ as well. Like you have more safety mechanisms, but it's way much slower, right? So I think it goes comes with that downside. But I find it a very pleasurable language to be very honest. But anyway, so what we did off screen, we just started off with a code of a guy that I didn't save, but we changed so much that I think we just removed all the stuff that he had from the stack.
No,
So
but
we
that
just took the stack.
the code that you brought from the stack, I found the Stack Overflow post very easily. I can add it later. That's fine. The
Yeah, but we
credits.
changed everything anyway. So there's not even the code the guy wrote. It's just the interface.
Yeah,
But
that's
anyway,
fair.
the so what we had to do is basically just do the stack so far. Uh, so the way we're gonna do is we probably should organize this in folders, but whatever. Just make a H file, and then how you define a class in Objective C is just interface name,
And
the
we
base
should
object for
emphasize that
inheritance.
there are more than one syntax way to
Yes,
do this,
so you
but we
can
are
put
using
like
the one that pleases Magetta more.
yes. So let's move this. I think it's less verbose and easier to read. Uh, then just like have the definitions in the .h file, and then we just do the implementation just fine as we would do in C++.
Is this working, by the way?
But
Have you tested? Oh, it is printing halting. Cool.
so what I did is I'll change to prove that it is working. I just added another one just to test.
The fact that we had to ditch the switch is so fucking sad.
Yes, we're well now it's basically the comparison because the problem with the switch was that this function here on the pop It's member actually, not function. Come on. That we wrote last time. We're basically just doing removing the last object, right, and picking the thing, which is the ID is the managed pointer
I
from Objective
read
C.
in Stack Overflow that this is basically the void star of Objective C.
Yes, it's a managed pointer from the. I mean, it's not equal to the void star as far as I know.
Yeah,
It's for the
probably not
class pointers.
100%.
So when you access a mutable, which is the thing we're using, when you access the NS mutable array, it will spit a ID that we can cast. So that's why it's a void, right? We can cast normally. The problem is that we need to compare, like on here, we need to compare based on the pointer as well. So these functions here, you cannot pass variables. You just pass the reference for the variable. So that is the weird part. So for example, when you look at here, the uh, oh, I don't have here, but
Wait.
ns log, which is the
Ca
print.
yeah, but can you go back to the is equal to? I don't think I get it. Which one are we doing the reference thing and we cannot
It's
cast?
oh man. So uh,
No,
sorry,
not
what
this
was
one.
the question? Which one?
Yeah,
Oh,
this.
this equal to.
Yeah.
If you can you see this?
Yes.
Okay, so is equal to returns a boolean, blah blah
Oh, no,
blah,
no, no.
and then
You're
you
talking
put
about
the
the window. I
ID.
can't see the window.
Oh man,
I can't see the window, yeah.
you can't see the window.
Yeah, I
You
can only
can't.
see. Yeah, I can't see the window. Sorry. I can only see the editor. I can see the hover.
Ah man, the problem is that I have work stuff open. So anyway, just trust me then.
Sure.
Uh, so the push here, sorry, not the push. The is equal to. If I click on this, it will say the signature is like this. I'll copy. It's this. It's a member from the say class member that is class member. I mean, sorry, instance member, right? That returns a boolean called this with this following argument,
Yeah.
which is taking an ID itself. So you need to pass an ID to it too, and the way you do it is with this thing here to transform it the literal into a ID, which is what they call as a non. If I type is equal, if I type like this, do you see the completion bubble?
No, I also don't see the completion.
Oh man, this is terrible. Let me close my stuff. Wait.
No, not a problem. But I think I understood. So you're basically grabbing a pointer and an object, and the pointer is probably being derefed inside the is equal to, and
Yeah.
then it's
Mm-hmm.
compare the objects. Which means basically that an enum is an yeah, it is an object because you're using ns integers, I think. So yeah, I think I got it. I think I got it. It is still sad, but I think I got it.
Oh, it is what it is. Can't do much
Marinho,
about it.
do
Yes.
you know where in the paper the guy's saying the sizes of each register? Or is this being said somewhere else?
The entire machine uses 32 bits for the word size, register size, memory cell size. It doesn't have byte addressing.
What about
It only addresses
address
by word.
register?
It's also 32 bits.
Meh, but okay.
I mean, there's no reason why we have to
What
do a
about
32-bit wide
what about we go
word.
for 31?
It wouldn't be the weirdest number, actually. There are some stack architectures with 21 bits or 18 bits per word, which is weirder, I think.
Close this and close this.
Yeah, I should have paid more attention to this paper. There is a lot more going on now that I think about it.
Can you guys see my whole screen?
Yeah, now I can
So
see
okay, now you
the
can see
auto.
completely,
I
right?
can see
Okay.
autocompleted. Yeah.
Okay, so you see that thing? Nullable, ID, blah blah.
Yeah.
So that's what I was talking about safety because it has all these things that you can put on the types, like if it's nullable, no null, like and such. Anyway, this is fine. Let's not stay too much on here. So I added add here, so it showed adding. So it is working, but I had to ditch the switch case because I cannot do this kind of comparison on the switch case.
Mm-hmm.
And we don't have pattern matching, which is sad. So anyway, uh, okay. So how do we start? What did
We
you want
go
to
to
do
the
again?
VM
Stack.
definition. We go to the VM definition, and we're gonna add more stuff there.
So let's
We
see.
need to add the
What?
computer parts to it. So we need to add a register, which apparently is called an address register. And a register is
So that
basically
should
a
be
32-bit
too.
value.
Wait, that is one register in specific,
Yeah,
right?
that is one register.
I'm thinking here, do you think it's worth doing it as a list, like as a fixed length list with all the registers and the
That
number of the registers, the
that could
Romany?
work, but that's actually a more appropriate way of implementing the backing storage for the stack, because the stack is essentially a fixed length array of registers, the way the machine works.
Wait, I need to ask stuff about that, Marinho. So what you're saying is that the stack is a list of registers? Are we gonna
Yes,
model that? I don't think
essentially.
so, right? Marinho?
I mean, if we don't, it if we don't, we won't have a stack like the way the paper defines a hardware stack. So I don't see why we would not
I
actually.
think we can abstract that out, no?
I mean, you could, but you would still have to say that there's an array of registers somewhere.
No, the array of register, I'm fine with it. I'm just saying that, well, at least that's how I am imagining. Correct me if I'm wrong, okay? So our program will be a sequence of instructions that we're gonna read them, and then we're
Yes.
gonna we're gonna actually I kind of joked in the beginning, but Mageta, the parsing on this type of stuff is the simplest parsing possible. There isn't much there isn't much thing to get a
Yeah,
headache
I think
about.
so.
Uh, but like correct me if I'm wrong,
Oh, by
Marinho.
the way, I started with this too. So got the ST from the program. So assuming that we were going to do a high level thing, but if we're just gonna do like instructions with three values, let's say, then well, this is trivial. And then just compile bytecode here. But anyway, I'll just remove it.
Okay, I just want to understand what Marinho said there. So my understanding would be that, for instance, we are reading the code, and then
Just missing.
we got, for instance, a push in the stack manipulation instruction set. We got the mnemonic that. What we would do, uh, we would pick the value of the register A, which we are just adding there, and we would put that on the data stack, which is just a stack out of integers 32s. That was my understanding. But you said that the stack is also composed out of registers, right?
Yes, it is.
Fuck. Okay.
So
So
yeah, like the way it works is you have the your stack, which as I said is an array of registers, and then there would probably some control bits that tell you which register is the current stop of the stack, and the operations will take that as their arguments basically.
Okay.
I really don't know if you should model that though. That's gonna be much harder than just
No,
abstracting
man,
it as a data structure.
it's basically just a ring buffer, man.
Oh yeah, you can do it. I'm just saying that I don't know if that's how that's easier than just having the abstract that to a stack, no, a normal stack. Yeah, I
So
think I should have read this before because for me we would do like Zozin did for some reason, and yeah, as we discussed before, it's completely different.
Yeah. By the way you actually load constants into the stack is not with the a arrow opcode. It's with the opcode called lit for literal.
No, 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 that part I got it as well. So there is a difference
And the
between putting stuff from registers into the stack and putting things directly into the stack.
Yeah, actually, the A register is meant for loop counters and other things because loop counters are really annoying if you don't have a special if you don't have special support for that.
Okay, so Magenta, we have a problem.
In a
I
sec.
think we're gonna have to remodel the stack with that in mind. That's what Marinho said before we can continue. Sadly enough. At least if you want to follow what the paper is saying more closely. If we want to just YOLO it, we're gonna have to understand that maybe things will not work because we changed it.
So okay, just tell me. I don't care about the decisions.
Okay,
Being
so
pragmatic today.
is is if a stack is a fixed array of registers, uh, then I have some questions. So how do you do a how do what does it mean to pop into the stack, Marin?
Pop. You basically you could erase the top of the stack, like the bits in it, set them to zeros. That's optional. What you actually have to do is just point the control bits that tell you which value is the top of the stack, which register, I mean. Just move them down basically by one.
And you read the value from the previous one, right?
Yeah, basically.
Okay, next question. So there will be a pointer that will tell us which register is the top of the stack, and then we're gonna assume that going to the right in the list is gonna going lower to the stack. How does that work? How do you know which direction if you're going up or down in the stack?
That's kind of arbitrary. I mentioned implementing this as a ring buffer because this way you don't have to do too much shuffling around of values at the implementation layer. If you want to implement this the way the hardware likely works is like uh, the most likely most likely there are circuits to move values along the stack like efficiently. And then one particular register is the top of the stack, and then that would remove the need to do the control bits. But then in our implementation, we would have to do a lot of shuffling around of values.
Wait,
So
wait. So when you push a value into the stack, that will be bits within the value being pushed that will tell which register to go in?
no, no, I mean there's the array of registers, which is the stack, right?
Sure.
When you push a new value into the stack, you're basically writing it to the top register, which is whatever register happens to be the current top of the stack. But then we would have to we would have to if we do a literal push down stack like the way it might be implemented in hardware, we would have to move the previous value of the top into whatever was below it and do that for every register, which strikes me as too much copying for a software implementation.
Yeah, but let's just stop right there. So let's do the following. Let's not change the stack today because that will take a lot of time. Let's just go with the abstracted stack for now, and let's make a tech debt to change the stack implementation to use the. For me, it's still a more inconvenient and harder way, but if it is the way that should be done, fuck it, let's go then. But let's make a tech debt of that,
All right.
uh, and let's just go with the stack that we already have. So let's just finish adding the registers. We have 8 registers now.
So okay, we're gonna go with fixed length, right? I think we should put it as a variable actually
Sure.
as well. So
At a
let me
press
put
of a
this stuff
button,
here.
we add more hardware.
Yes, we
If
buy a
only it
GPU
was that
online. We download the GPU online. Uh,
I mean, if you're running an FPGA, that kind of works.
uh, register size. Let's start with 8. I suppose we cannot do this. Funny enough. So we would need to set it up here. Their size equals 8, and then this takes a new integer, so we can pass the variable here. Okay,
Okay, so the
that's
next
it.
thing that I think we should do, we should have create a mechanism that we will be able to say register A instead of saying register 0, because that would be very inconvenient. You know what I mean?
I agree. I agree, like a table, right? A map
In
mapping
num,
stuff.
maybe?
Yeah,
Uh,
actually, it would probably be nicer to call it top, as in the top of the stack, because like A is usually the name of an index register, which is the case in the paper, by the way. So that's not
my
part of the
question
actual
is,
stack.
can't we just do the mechanism for the opcodes now to manage the stack instead of doing this labeling?
No,
Because
we
that's
can.
Okay,
No, we
trivial.
can. No, but
we
that's the
can.
thing. The opcodes that we're going to implement, they will reference the registers. That's the thing. So for instance, stack
Oh,
manipulations.
I see. So
Stack
you want to do
manipulation.
something like, I get what you mean. So you want to do something like add, right? And then you want to put like R1, R2, whatever,
Well, we're not
right?
gonna.
Something
It's not
like
gonna be
this.
exactly like that because the add will already say it's a mnemonic that will already have the register embedded
Yeah,
into it.
okay. You could just run this and it already gets the last 2 points on the stack.
Yeah.
Yes.
So
But
what
okay,
I'm suggesting
the
is to make an enum of like registers names or whatever, and then the first one it will be A because A will be the zero index in the registers
so let
array.
me see how that works because as we increase, we're just gonna increase more in the enum, right?
Yeah. We're gonna increase the enum, and then we only gonna reference the index of the registers using the enum's names.
First question.
Then
Let me
Go on,
do one thing here.
Magita.
It's actually a test I want to do. So let me make a
Marinho,
new
you
file.
wanted to say something as well?
yeah, actually, doing an enum, unless you take care to always make the A mean the top of the stack and the B to mean the one below that, and so on, you will have a problem if you increase the stack size.
No, but the A will always be the top and B will always be the, well, assuming that the top is index 0, right?
Why don't you call it top?
That's what the paper does, actually. It calls it top.
Like, man, the problem seems to be just the name. Like,
No, I'm following the table, the name that is in the table of the instructions. That's why I said A there.
so
You're
okay, the
still
first is
talking
top,
about the
then the
first is top.
second.
Yeah, and then the paper calls everything below that the data stack, as in with the letters DS, the acronym. But whenever it says that an operation takes a value from the DS, it actually means it takes the value below the top. Like sometimes it uses DS to mean the entire stack, and sometimes it means the second value of it,
Can't we
depending on
just
the
use A,
context.
B, C, D?
Yeah, but that
That's
needs to be B C D for now. Yeah, just put B C D A F G man there.
that's kind of the thing. Like most opcodes
X,
take one or two values,
0,
right? So you only really need the top, and whatever is below the top,
X1,
we may decide to name that something convenient.
X3. Can I just put X on everything?
Yeah, you can do that.
That's
What is
good.
that table that you're talking about, Marinho, please?
Like there's a diagram
On chapter 6?
on chapter 6 at the very beginning. Yes.
Yeah, I remember that, but I'm pretty sure it's written A, not top. Let me double check that.
No, it's written top. There's the top register, which is the value on the top of the stack, and you'll see that basically everything is connected to it. And then the A register, as I said, it is specifically for loops, like to make them more
Oops.
convenient, because otherwise you have to take care to shuffle around the loop index while operating on the actual values you're interested in.
Okay, but uh, then I have another question. Going with that figure, we have names here. We have the top, but we also have A. We have the program counter, right? We have R. shouldn't we name our stuff with that? Because we're gonna have to map the x's into those names. Do you agree
We
with that?
probably, yeah, I do agree with that actually. Um, it would probably be convenient so we don't get lost. Um,
Yeah. Okay. So, Magetta, go back to the enum.
Wait a second.
So, which one of these guys are registers actually? We have the
uh,
program counter. So one of these needs to be PC, Magetta.
So let's do it the last one.
Shouldn't PC be like
Man,
separate
what I
from
don't
this?
like of this approach is that if we increase the number of registers, we're gonna exponentially increase the number of members in the enum. And second, imagine that we say, okay, let's add PC. Like we cannot add on the top and be compatible with the code that we had previously because it's gonna try to access like the first position, but it's not anymore, right?
Yeah, some
The
registers
same
they
goes
have
for
fixed
like
they have fixed stuff.
yeah, and then if you put stuff like PC here, then if we say okay, let's keep adding more, and then we just put like W0 like after, you know what I mean?
Yeah.
yeah, like one of the points of writing code for a stack machine is that you usually don't have to worry about that. Like you don't have to put the actual names of the location inside of the
Yeah.
processor
So
to
what
call your
about we
instruction.
do? What about we do the treat them as strings, and then we just do it. We just happen to do a function that converts the string to a number. Like that's sort of what we were planning to do, I guess.
Oh, you mean making a hash map?
Yeah, but yeah,
Sure,
on strings.
I
sure.
So
guess
we
that
gotta
works.
discover how to do a hash map in
Okay, Marinho,
Objective-C.
let's go. So you have register A, you have PC, you have R. So you have at least three registers, right?
But there's stop as well.
Top,
So
sorry, so we have four.
and
Uh,
then DS and RS are arrays of registers as well. They are the data stack and the return stack.
yeah, but that we're gonna not do that now. That's what I said about the making the tech depth.
But just a sec, like instead of handling them as a list, isn't it better just to handle the registers in the map if we're gonna do this anyway? Then we
That
don't have a
depends.
problem
Are
with
there
ordering
operations that are based on the fact that the registers are in an array, Marinho?
order,
Yeah, in
like
an
Uh,
order.
in a sequence.
Yeah, in a sequence.
for for this particular architecture, no, but there are some variants that treat the stack as an actual
Contiguous.
ring buffer, uh, which we may not want to do.
Yeah,
We may
so
or may not do.
so let's do the hash
So
map for now. Let's do the
bye
hash map.
bye. So hash table.
They do have a hash table, huh?
If they didn't, I would cry.
You would
Okay, we
cry? That's
discover how to
fair.
instantiate that. Hash table, hash table with options, and as pointer functions. I suppose you can pass your own. For now, we don't need this. And I think we're gonna need this with init, by, and by to you as well. So we don't know the size anymore. Oh, we can consult from here, supposedly. So let's see. Um,
So we're gonna have four
count.
registers. Um,
Oh, it does count. Okay, perfect. We're gonna use the hashtag. Okay, so
return stack.
okay, what we do now?
Okay, now you go back to the VM implementation.
I am already.
And no, not sorry, not implementation. The header. I should say definition. Sorry. So you're gonna rename the stack that we have on line 16 to data stack,
Ah man,
and you're gonna
because we're gonna
also
have more stacks, right? I
and we're
get
gonna have
it.
another stack called the return stack.
Okay.
Okay, so that's already there. Uh, memory. How many registers? Oh, how many? Go back now to the implementation of the registers. Let's see the ones that we have there. So we
Oh,
should
what do
already
you mean?
make the.
Is this?
Yeah, now the stack. You should just do a rename of stack to data stack globally, man.
I hide macOS, man. How do I rename everything? Refactor? What?
The rename is there, but it doesn't allow you to click.
It's so sad.
Uh, the mar is also another register, right? Marin.
I don't think so. That's a block diagram.
No, but it's saying on the
So
memory subsystem saying memory address register.
memory address register might be. I don't recall. It's been a while since I last read that paper.
Okay, so Maget, there's a catch there. So when you initialize the VM with the registers, we need to actually put data in there. We need to actually fulfill the hash map.
Okay, but what data?
We'll make the data from a string to a number, right? Yeah, a string to a number. And then we
Wait,
already
I
have
need to do
a few ones.
a string for a number.
Yeah, that's the map. The key is going to be a string and the value is going to be a number.
Yeah, but I don't need to initialize that.
Yeah, we do because we already have the names here and the numbers.
Yeah, but you can literally just the first time you access, you can put the name there.
Why we wouldn't want to do that in the initialization of the VM though?
Why would you want to do that?
Because then I just call in initialize from the caller points of view and I don't have to care about putting the names of the registers and their indexes in the
But
map.
in the case that I'm saying you don't. Like you have this as a table. Oops. You have this as a table, right?
Hmm.
And then you have nothing the first time. And then you say, okay, try adding for me on the A this thing. And then you just go there. Okay, there's no A. So create A referencing one. Oh,
Oh.
I want to add B. Oh, there's no B, so just add B.
Oh, okay, that works. That
Oh,
works.
I there's no there's already an A and I want to access. Oh, just access one. Oh, I want C to access, to load. Oh, there's no C, so there's nothing. So it's zero, right? So we need just a default value, which we can handle on the hash fetch, probably. Just gotta see. Right,
Okay.
get. Okay, we have intersect. Do we have get? No. Find. Search. Filter. Hold on. Just help me out here. Yeah, it's based on a set, so we don't have that problem.
Okay. Okay, cool then.
Now here. Any object count contains member in search. How do we get an object though? Would be useless if we can do
We
it.
can
We
add,
can
can
get.
remove.
Oh, member.
Member, yeah.
Oh, whether or not the object has contain object,
No, no,
all
it is
object,
that. Continue reading there. Determines whether
and
the
it
hash.
returns the object.
Yeah,
Okay. I just didn't read.
yeah.
Okay, I'll keep
Okay,
this open. It's useful.
okay. So let's. Okay, now I think we can start then. We already have the registers. We already have the return stack, the data stack.
Okay, so
Uh,
just dictate.
okay, so go to the enum of the opcodes and yeah, let's go with that. We're gonna have to make detect depth very fast, but okay. So let's just start with stack manipulation. So add an OP called uh, OP push. I'm gonna name it like that, not using the mnemonic because I don't even know if it's possible to use the mnemonic here. Let's
Let's
try actually.
call it push to A,
Push
and
to
then
A, push to A. Yeah, that's better.
because there's also the R register which we can access, which is the
Push,
top of
it's
the return
pop-A.
stack.
Pop-A also exists. So the next one is dup for duplicate top of the stack, of the data stack, sorry. Drop, uh, pop, OP, pop R, and push R.
Let's put in order.
Which order?
Push and pop first. I did like this, so I'll change the order here. That'll be first.
Okay. Uh,
Okay, what else? Just this?
yeah, for now, just that, because that's the entirety of the stack manipulation mnemonics.
You forgot the over
Oh, the over,
instruction.
sorry, I also forgot the over. The over goes after the drop in the paper.
Think about it. Over just means push the top onto the DS.
Push copy of second element. Yeah. Uh, okay, so that's about it for stack manipulation. So let's go now to, yes, to this evaluation. And now we're gonna do the L. Well, so
The
fucking.
if else ifs for everything. Okay, which one first?
Well, let's go with push to A first.
Okay. I'll put logs here so we can see what we're doing.
Sure. So the push to A is grabbing the data out of the A. So this is kind of assuming that we already have the stack based on registers, right? But as far as I can tell,
Uh,
Marinho, A is also always the top of the stack, right?
no. Top is the top of the stack.
Oh,
A
top is the
is
top of the
a
stack.
is the address register. As I said, it's used for holding addresses and loop indices
Yeah, yeah, no,
because
yeah, you mentioned that.
yeah. Uh,
Let me think about that though. Wait a second.
Just explain me what I have to do. I
No, okay, so
just
let me
explain that
explain
because I
what we
didn't
have
read.
to do. These, the push and pop ones about the A registers and the R registers.
Right.
Um, Actually, it's on an R register. It's doing push to A and push to A specifically, and pop to A. Pop from A.
First of
Actually,
all,
should
what
change.
does A means? What
A
does
is
A
a
mean?
register. A is a
I get
register.
it, but why? What's the difference between A and R?
A
Um,
is, as I said, it's for indices. R is actually the top of the return stack.
The results.
So
Okay. Mhm.
yeah.
not results, it's for return addresses actually.
Actually, that's a little bit confusing. R is actually a register as well.
That's
But
that's because that's R is kind of like top, except top is the top of the data stack, R is the top
Yeah,
of the
yeah.
return
The
stack.
return stack. Okay.
yeah. So what we should need to do on the push to A? When we do the push to A, we grab the value out of the A register and we push that to the data stack. The problem is that we don't have the notion of registers because we didn't remodel the entire stack to follow this mindset of a stack is basically an array of registers. We didn't do that.
We do have an abstract stack at least, don't we? So we can just, for the time being, take the value A from the
Okay,
So
register
so what
A.
we're gonna do? You're
in
gonna
our
do a
case, it would
lookup
be
in the hash table, searching for A, grab the value out of that, and push that to the data stack. That's
but
what we need to do.
just one thing. Doesn't it need to be A alone is a register? It's not like A. You have multiple A's, right? Because
No, you
I
don't have
recall that in
multiple A's.
Meeps. Okay, because I recall in Meeps you had like R1, R2, R3,
Yeah, yeah, yeah,
S1.
yeah, yeah,
Like,
although we should
okay,
try to
so
keep the bias from x86 far from this.
Yeah,
Uh,
x86 is a completely different beast.
yeah. So what we're gonna do, Magita, we're gonna do a lookup into our hash table, searching for the A, right? A
what was the function again?
member.
Was it member? Yes.
So you're actually gonna do an if there, right? Because we need to check actually if we got something. Because it's as far as I can tell, we
Yeah.
can return null, right?
which
So
we
it
don't
returns an
rely on.
ID.
Well, if
And
and when we make that company, we're not gonna do any of this. But well, that's really
okay,
far
so
in the future.
member, then we need to pass as a pointer. Uh,
Ask for the A there.
okay, I ask for, oh, just the string, right?
Yeah,
Hey, it's not much.
yeah. Then we're gonna check if this actually is a thing.
Beautiful, Desmond.
It's a little
So
bit
what does it
nostalgic, to be honest.
return? What does it return?
It returns the object.
Or what? That's the point.
Determines whether the hash. We can check that out, right? We're gonna compile in the scene in a press of on a press of a button.
Oh, that is true, but how do I would need to print this, right? That's the
No,
part of
no.
the
Let's
problem.
just assume that this is gonna be new or an object.
Okay, so if I do this, I should get something, right?
Yes.
But we go through the risk of the value being zero, and then it would fail. So let's just go with this. So
Wait.
ns dot
Ah, so if the member implementation is crap, we are fucked. Yeah, that's true. If they actually return zero instead of new or whatever. Ah,
did I push? No. So let's push this. Push
push
A.
A. Yeah. And yeah, push A.
Nope. Okay. So it actually
Um,
returns nothing. But can I print this point? I think it's a pointer, so I probably can print as a mask of E, maybe? Value of A. Let's see if my C days are. Yes, sir. So it is actually zero.
Okay, so it is crap
oh,
then.
Uh, yeah, but my question is if I do this, can I type the
Yes,
memory?
I saw this on Stack Overflow.
I can. So
oh,
let me think this way. If we put something like,
No, but then we are completely fucked. What if A has
what?
zero as well?
yeah, it
Yeah,
will be
what?
still zero, right? Actually, I don't know. I don't know about that. Let's see here. On the init, I'll do this funny thing here. How do I add something there? Any object, comparing,
Add object.
this, add object, probably. It's the same as the list, the array. So this,
Oh,
and we're gonna add. Oh, but wait, I need to add the key, right, and the value.
Yeah, you need to add the key
yeah,
and the value.
the
How
key
do I
is
do?
A.
Yeah, but how do I add the key and the value?
That's a very good question.
Add the
I
object
gotta be
or just
honest.
add
It's
the
really
object?
cool that this is in. You didn't have to install any of this crap, right? This came with Xcode.
Yeah,
Yeah, that's cool. So sad it is a dead language, but it is cool.
add object. Yeah, it's just add object, but that's just a generic function to add on enumerables.
That doesn't really make sense actually. What is the difference between a hash table and a map table, by the way?
Map table. Similar to a dictionary, but we've brought. Oh, I think at the hash table, it will pick the things based on the
Oh, the hash table
memory.
is actually a set,
Oh, that is a
apparently.
Yeah,
set,
so
so we actually need a
no,
map
both
table.
are no. Both are based on the sets.
No, no, no. Look at
Both are
the main
based on sets.
description. Look at the first description there.
Yeah,
The,
yeah, but this has the this is the hash will take based on the value, right? So it will compare and hash the value first to
yeah, but look
choose
at
where
there.
to store.
A collection similar
I
to a
know, I
set, and
know.
the one
So
is a
it's
collection
this
similar to a dictionary. What the fuck they call the
set.
hash table a set? What? Eh, so weird.
No, it is right. It's a hash. It's picking the value based on the what the value is.
Yeah, but when you say a table, my intuition just tells me, man, this is a pair. This is a list of pairs of
All right.
keys and
Oh,
values.
I associate that a map actually because that's what they name in F sharp too. But
Yeah, yeah,
anyways,
yeah. I understand that.
okay. So this is substantially easier than I thought. Okay, so let's change that. No, hash table, map table, and then you're gonna do table. Um, so let's try to write something to
No,
it.
but now you can go to the documentation and see how the heck you add a pair of things.
I just saw here. Where? Manipulating content. Set object for the key.
Ah. Yeah, put 0
So
there,
set object. Let's put 0.
and for the key you're gonna put. Man, this is so small talky. The fact that you are gluing things.
Oh no, that's actually wrong. It doesn't understand. I thought it would. I just wanted to see actually. Um, for the key A, right?
Yeah,
We're
the key
using.
A. Yeah, that's what we want. I think we are fucked if the member function doesn't like. What do you mean? Oh, but now we are not using hash tables. We are using map tables. Maybe we have a better function now. Please, please.
Okay, how do I get the value now? Man, this window management on macOS is horrible. Accessing the
uh,
content. Object for key.
what is the return of that?
Probably ID as well.
No, yeah, yeah, but
Yeah, it is an ID. Uh, okay, so let's see if it matches with this.
it does.
Uh,
Okay, go back to the documentation. Let's see if there is a specific function to check if a key exists.
yeah, that'll be better. But then
That
I
that
think
would be
it's
a must because
better
otherwise
to.
we are just fucked. Uh,
No,
please,
I
please.
mean we
Hello,
could get the
Naka.
enumerator with the keys and filter, right? That's an option.
Oh, I can't believe it though. I can't believe it. How do you make a library of hash tables like dictionaries and you don't
Man,
have such a
I
function?
think I think they don't, man.
How do
Oh
you
man, this
do
is
that?
uh, key. Let me see. Value for key.
I saw a function value for undefined key. What is that?
Value for undefined key. Now let me type. Value for undefined. Invoked by value for key when it finds no property corresponding to a given name. Okay, it doesn't tell me what it does. It's just where it's used, but it gives you a ID nullable.
Uh,
Oh, can't we? If we okay, if null is the same thing virtually as comparing address zero, right? So uh,
I have a question. There is such a thing as an NS integer, right?
yeah.
yes,
Uh,
hmm
is the bit representation of the NS integer 0 the same as null?
that's a good question because one is a class, the other is because you have primitives as well. Let's see. Let's see. How do we know that? Because we could put like this here. Uh, like this is equivalent to do the NS number in this case. Or we could do this NS number. No, let me put like this. Uh, with number, number with int, and then you put like 0 here. Like this is equivalent, because then when we get back, what? What is wrong now? No visible interface for an SM.
Yeah, the value for something something seems to be.
Oh, you were typing there and
Oh,
then
right.
we went elsewhere.
Yeah. So what was the name? Value for key. Let's
Oh
see.
wait. Whatever object for key returns, it actually returns an object type question mark. What is an object type question mark?
Whatever this returns.
Okay, okay.
What returns what, man?
No. If you go back to the documentation, I'm also reading the documentation on
Which
Apple's
one?
website. The
From
one
which
for
one?
map table, there is a function called object. Object
Right.
for key, actually. Object for
Yeah, which
key.
is what we're,
Yeah,
which
but it
is
is
when.
not saying the type signature there. In Apple's website, it is. And in Apple's website, the return type of this is an object type
Oh,
question
here.
mark.
The value associated with a key or new if no value was associated with a key.
That means that if we ask for B now, we should go to the nope, right?
Okay, I did this here that I will roll back, and then I'll use object for
Object
key.
for key. How the fuck the implementation in Apple's
So
website is not
so
giving you.
zero, so zero, new, empty class. Those are all the same thing. Awesome.
No. But I don't think this is actually testing what we want to test. Go to the beginning, go to the initialization and comment that line out now.
Hmm.
Yeah, now you run. Yes, so it works. Oh no. The
What do you
other
mean?
test that you just did means that new is equal to
Oh,
0. Yes.
yeah. So one of them is, so as long as it's different. Actually, here it should be different. So it should go nope, right? It didn't. It did go nope. So we have one value, and it's different than you. So that is fine. It's
That is
0.
fine. That is fine. That unfucks us because if we
So
couldn't do that.
if it is like this, but if we don't have it, and we find and we try to find, it also goes to here. So it is something else instead.
No, wait, I'm confused. In the case that you have,
Both
uh,
are both are going to nope. So both cases are different than you, which is weird.
I found a thing on Stack Overflow.
Uh,
is equal to new, maybe? Yes. What did you find? What did you find, Marinho? Detect if S number is 0, new or 0. ah.
People suffered as well.
To check the numeric value stored in an NS number, you have to call one of the methods which give you a primitive type. What?
Yeah, but this actually doesn't tell you how to tell apart zero from nil. It's kind of sad.
Wait, what you did there, Magetta? Did that work for us?
No.
No?
Feel like it's saying it's equals to new, so it's false, and then it went to none, although I don't have it.
No, but that is correct then. That is
No,
that case we
that's
want. Yes, we are searching for A. There isn't an A, so it. Oh,
no,
it went to nope.
that that there is no, man. I'll rewrite this. There is no way. There is a way. I'll type a way. So there is a way, which is false because there is none. You see?
ah, okay.
So there is no way to tell apart, this way at least. There's no way to compare the return of this thing. We could try to cast, like, we are inserting numbers, let's say. But that's not always true, right? We might not insert numbers at some
No, we
point.
are always inserting numbers on that map table. Those are register values, so this
So
is
on the
always a
registers, we
number.
will always insert just numbers.
Yeah, that's what registers do, no? We
Aren't we
only insert
inserting
bits.
bytes?
No. We can insert bytes, but we are just abstracting them out to have numbers just for their simplicity. But we're gonna manipulate that
Yeah,
the
okay.
numbers later.
Because bytes, I don't think there's a way to tell because it will like if it is zero, it's always going to be zero. Right?
No,
Is that an
yes.
actual problem though?
What if we store zero? I mean, that's a hack, and then we would need to do some crazy stuff like Okamo.
Wait, I'm
Uh,
confused. What do you mean?
like I don't know, consider the negative 255 like overflow, whatever, a zero. Like that's possible.
Oh, you mean shifting the
Yeah, but
integer axis?
yes, but then like to set zero as a specific number, but then you have to disallow the number to be something else. See?
Yeah.
I
That
mean,
would be
is
very
it
very
actually
slow.
a problem that the we can't tell apart zero from nulls? Because consider this: we are trying to look for a default value for the register, which we kind of already decided will be zero, right?
Hmm.
If there is no value associated with the register, we get a value that's indistinguishable from zero. But is that actually a problem since we do want the default to be zero?
Oh, I
Yeah,
see
that
what my
I
Marinho is
see.
saying.
Makes sense. Yeah, and makes no. There's no point on checking because the value will be the same, right? It will be zero. So okay, if we push and then we just check if we have a value, which should be simple because we can just check the reference. This, then what we do?
Then you grab that value and you push that into the data stack. That's what we do.
So okay,
I believe otherwise.
wait, the return stack, right?
No, not the data stack. The data stack.
Okay, we're not computing anything to turn that. Okay.
Yeah, not now.
We're just shuffling
Uh,
data around.
Yeah.
what was the? I think it's add.
Oh, you
No,
have up
add
there, no?
observer.
In a comment?
I forgot.
Yeah, there.
Oh, push. We wrote this stuff, right? Forgot
And I'm
about
gonna
that.
have to. Someone's gonna have to rewrote that, which is kind of sad, but okay.
Value of A. Oops.
Is there a point to doing that conditional? Because if the value of a happens to be zero, we will push a zero to the top of the data stack, which would make both
Oh,
arms of the if the same, right?
Wait, I'm kind of confused. Marinho. And there is a problem if you push zero into the stack, right?
No, there isn't, because you may be pushing, I don't know, maybe you're summing some numbers and you're pushing the starting number and it happens to be zero.
No. If you purposely want, like the user is for some random reason using our assembly to make his program, if the guy wants to push zero to the data stack in order to do whatever, that's fine. What
But
I
that's not what the opcode is actually doing. The opcode is saying there's a value in the A register and I want to push it into the data stack. If the value happens to be zero, the correct semantics is to push a zero into the data stack.
No. Let me make myself clear. The check on the if, this is implementation details. This is because we are modeling the registers as a map table. That's why the if is there. Because if it happens that someone called an evaluation but didn't initialize the registers, this should explode in his face. The if is not because of the semantics. The if is because of the implementation.
that's a very mean
Okay.
way to say it, by the way.
A mean way? What do you mean?
That should be explode on his face,
Ah,
like what
okay.
the heck it is.
Let's do pop A now.
Oh, what do we do on the else?
We should explode.
So how do we explode here? Just return? We should log as well, right?
We should
What's
error
happening?
out.
Like exit.
Yeah. No, we should tell the user why first, but then we should exit one.
Just
We should
just
go.
kill the program.
Yeah, you didn't initialize, you didn't buy hardware. But that's basically what we were saying. Go buy hardware, motherfucker.
Um wait, attempting wait. Attempting to push to uni
No, no, no. Attempt to push value from undefined register, a register.
Oh, I didn't hear the reaction to what I said because my internet decided to fail right on that moment.
Um, can you repeat
this
again?
message ridiculous.
Like if there is no value, we should make some demons fly out of the user's nose.
Yeah, pretty much. Okay, next one is pop A, right? So pop A, it's basically the opposite. We're gonna pop a value from the stack.
Just a
Uh,
second. Why is he complaining on the exit? Huh? What do you mean? Oh,
expected.
you kidding me? No, it is not.
Yeah, but it's expecting a insert. Click on the fix though.
Oh no, you're kidding me.
There's no way.
Quest what?
Expression
Question
result used. What the heck?
is exit a keyword or a function in Objective C?
That's a good question. Oh, it returns.
Oh,
Wait.
it just calls out to C's exit. Okay, so it's
Yeah,
actually
so
a
it's
function.
std_lib. So
So this is a function. You need to pass an argument.
funny, isn't it?
Wait.
Expected identifier. Man, I don't get it. It's like it's a function or not because
The
No,
documentation
it's
there
a C
seem to be a
function.
function.
it's not an object, so it's not
It's a
like
C
with the
function.
yes, but it's not with this, so it should be just this, right? Oh,
Yeah.
it's the parentheses keyway.
Yeah, so it is like a C function. It is not an Objective C function. Cool.
Okay, so pop
The
a
pop A is
now.
basically the reverse. So you grab the
So
data from the stack and you put that into A. So you're basically gonna do a pop from the data stack. Yeah. You don't need to pass anything. That's gonna be value of data stack, not value of A. Well, you can call it value of A because you're gonna put on the A anyway.
yeah, whatever.
Now you do an insert on the, yeah, you're gonna do that. You're gonna do whatever the name is.
That was a another one, which is what I used here. Uh,
Yeah, set object for key. And Marinho left for some reason.
he dislikes you. I can understand.
And he's back.
So, oh, he broke
I
my.
mistype. Yeah. The disadvantage of using a Dvorak keyboard is that the W is right next to the V and Control W closes the tab on Chrome.
Okay, so attempting to
To
pop
pop value from empty stack.
non-existent value from empty stack. So what
Nice.
happens if we try to pop? By the way, okay, we
Actually, it should
throw
not
an
be
error.
possible because it throws an exception.
Oh, actually, yeah. So this is the kind of design I dislike. So I think, by the way, instead of this, we should just throw.
Why do you dislike such design?
because we are duplicating validations, right?
We are, yeah.
And then it means that if we, but the problem is if we remove the double check from this place and rely on the implementation of this, if we change this library, you gotta remember to go here and fix it.
Or you can make a try catch on that, because the pop may throw, right?
Uh, so in this case, what we call the exception with name.
Uh,
Oh, just go that,
uh,
whatever.
just for the lols, I would put the exception with name by hardware,
It's
because
not
this
really
is a
hardware. It's
register not in
something
the
like,
computer.
should I remove it?
I think we should actually add a try catch if Objective C has it, because
Uh,
pop will throw and then we don't have to revalidate. We just throw it again.
Makes sense. So try. This is the try catch. Beautiful, isn't it?
Okay, there is an Apple forum with the try catch.
Ah, it is here already. This, and then
We don't need to finally.
we just rethrow the exception, I
Yeah, we
guess.
just rethrow.
Ah, let's just put it like this. Uh, man, if Marin pressed the button again,
No,
that
no,
would be
no.
funny.
This time was not a.
Okay,
Too good, man. Too good. Okay,
maybe not
so
then suffer. Oh, by the way, we are returning. We shouldn't.
yeah.
In
Okay,
the help
next.
him.
Next, dup.
So, oh, we still need to do the B, right?
Oh no, the B is not in the stack manipulation. It is. We have the R though. Do you want to do the R
They are,
first?
yes.
Okay.
Yeah, let's just do on the same place.
Okay, so the R is push R and pop R.
it's
So
basically the same thing, except
but you
except
instead of A, you're gonna do the return stack things.
yeah, instead of just you have to deal with the fact that R is actually the top of the return stack. So
Yeah.
when you when you when you push R, you actually have to pop the return stack, put the value that was on the top of the return stack on R, and then take the value that was on R and put it on the data stack.
Yeah, yeah, yeah.
wait, so go by pieces. Wait.
Wait,
So
do we actually need a separate R register at this point though? Because we don't have an explicit top either, do we?
We don't have registers, Marinho. Our computer doesn't have registers. We add them on demand.
Okay.
So we are doing push R. Which one of these ones we're gonna call push R? I think the first one. Okay, so what do you need to do, Mageta? You need to pop in push R. You need to pop from the data stack, and you need
and
to add
insert
that
on the.
value into the return stack.
Okay, so value of R here will be uh I get it from the
Data,
data stack.
yeah,
So pop, so I get the latest one,
yeah.
and then I check if I have something. Uh,
Actually, if you don't have anything, you're
ooh,
just gonna throw, right?
Yeah, you're gonna
yeah.
do the same try
So,
catch that we did before.
but here's I just something I noticed just now. If it's zero, it's gonna fail, right? You should just ignore this case.
Wait. No, 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 no. That's the same thing that I told Marinho. So what we need to do, this if that we have here is if you don't have in our registers. That's why we need the if. Maybe the
Here's a
condition is wrong.
No,
here's a
yes,
thought.
but the point is, if somebody pushed zero, it will handle and it will throw the same error. But zero is different than nothing.
Yeah, that's a problem. I agree.
So I remember we discussed. I thought at the time that we were talking about this that okay, fine. We if we keep going, that would be fine, right? But what about the case that we actually don't have it? So in
Ah,
my the way I see is that we would need to check on the keys if this key already exists, which sucky, but
Oh, you mean doing the filter on the enum?
yeah.
Yeah, yeah. To remove the if there's
Not
no other
not on
alternative.
the enum, on the enumerable. You mean, right?
Yeah, the enumerable.
So
Yeah, yeah.
something like this
But we need such.
registers.
What I want to say is that we need a check. Maybe the if is the wrong check, but we need a check because this is an implementation limitation. Let's say because when
Synaptic
you buy
keys
the computer,
remain.
there is already a register. We don't. We in our case we don't maybe.
Oh, let's go back here. Let's see. Key enumerator. This thing here. So we will need to do this.
It's so
Key
fucking ridiculous.
enumerator.
Just a moment, just for a moment of 30 seconds of rant. How the fuck they made a library about dictionaries? They don't have this.
Yeah,
Like, what
this
are you
is
guys
pretty
doing?
crazy. So can we filter? It's enumerator, right? I suppose that we have some kind of filter. I'm not gonna do a for loop. Sorry. An S enumerator. Next object. Apparently they don't. Kill me. Filter. Oh man. Find.
Let's
Loop.
see. Filter in Objective
Ah
C.
man, dude. I'm gonna
Yeah,
have
but
to do
I gotta
this.
say that this sounds like a very FP thing to have, unfortunately.
Ah, okay, so bool found equals false.
So nostalgic though.
Uh,
Oh,
for
okay, okay. I see what they did. They actually said we need it, and then they made it built-in in Swift. Okay.
ah, dude. Okay, so if we okay,
Ah.
so for it's this is a do we have a for each? Man, if we have a for each, that's all I take. I don't care.
I would be less bothered by a thing.
Uh, Objective C for each loop. Okay, so they do. It's the like Pythonized version. Okay, I can take that. So for uh key, and we need a type for it, and I suppose it's a string. Oops, an S
Oh,
string
they have a very fancy way of doing
pointer
this actually. They have
in
a thing called
this
NS predicate, my friend.
an S
What the fuck
predicate.
is that? Yeah.
If key,
Oh, they do have a
it's
filter actually, but I don't know if they have a filter in the numerator.
which sucks. Can we cast a numerator to a list or
An
something else?
array, they have filters in arrays.
Can we
Uh,
cast the numerator to an array? If we can, then fine. I won't complain that much.
I will complain in all cases, but
Is equal to string, and then we pass the other
okay,
string,
you can
which is
convert an
the.
array to a numerator. Okay, let's see if we
Oh,
can do
now that I
the other
wrote
way
a array
around. No, no, no.
procedural code.
We need the other way around though.
No, we don't.
We do. We don't have
Oh
an
wait, you
array.
said array to a numerator,
Yes,
right?
yes.
Right. Misunderstood.
Uh,
Is equal to
I'm not
string.
really sure.
To be honest, we can write those. Man, we can write some standard lib and use.
Isn't
But
an
whatever.
enumerator a potentially infinite thing? It would be kind of dangerous if there was a primitive to turn it into an array, right?
Oh, that's true, actually.
But they do apparently. Well, at least according to this
No, no,
website.
they do the opposite, right? Which is a
Oh,
fixed
Marinho
length
said the
string.
opposite of what I said.
Yeah,
Oh,
yeah.
okay.
So anyway, let's go with this, and then otherwise we can try to do something later. So if we found something, then we just say, "I found it." So found becomes true, and we break.
Okay, so whatever Rust did with iterators, they lost the race because apparently enumerators they have a function called make iterator.
It's not about losing the race here, but well.
And it
Okay,
runs on
so
iPads or macOS. Apple, man.
if found, then we just push. Otherwise, okay, that's it.
Yeah, then
Cringe.
you're gonna have to. Yeah, you already did. Nice. We should test this
Uh,
actually.
we should write a actually should make a function out of this because we're gonna use it everywhere. Or
Is it
should I
time to
say?
make an uchu.m?
Here
Is
we
it time?
go. Man, there's no single project that I type that ends up without a utils file. It's impressive. It's pretty
Well,
impressive.
when you are dealing with a language without a filter, I guess that makes sense.
Utilities. I'm gonna regret this so bad later. Implementation.
I mean, if you
No.
wanna be pedantic, you didn't create a utils file, so you're safe, actually.
We are right now.
No, but we have an utilities file. Ah. Wait, why are we gonna make a class out of this?
Well, why not?
But why? We
Because at
just.
least we have at least we have the stuff that we can look and see. Okay, we have all these functions here.
But isn't this already in the name of the file, man? Like you,
Utilities,
yeah, you
yes.
you click. Yeah, why do we need to make a class out of it?
Because well, it's not a class. It's just to well, it is a class. But my point is just I just want a header. I mean, we can do this. That's fine.
Yeah, that
Uh,
I was more thinking about the C style
yeah,
utilities.
yeah, okay, okay. So let's just do a. I think we can do the Objective C loosely defined stuff.
If we can't, there, I don't like were these guys thinking? Like I don't understand.
Find uh this. Suppose we don't need anything.
Ooh,
Can we do
but
this?
do they have functions as
Oh
high
man,
class
what we're
citizens?
saying, we can write just C normally. We can write C++ actually.
No, no. Let's try to make a Objective C alternative.
Utilities.
Is this gonna work with C using Objective C syntax?
Yeah. No, no, not C, right? But it works with oh man, what the heck? I did create C. I thought of creating Objective C and I didn't
Ah,
create C.
okay. I have another question though. Filters receive a function for the predicate. Does Objective C Was Objective C ahead of its time and made functions high class citizens
Spoiler,
ahead of its
no.
time in terms of imperative languages? Okay, I know Lisp did it already. I know, but maybe in the imperative world they did it.
I mean, theoretically, Objective-C is based on Smalltalk, right? I'm pretty sure Smalltalk had first-class functions.
Oh my fuck! There is a blog post about it.
I think there are no functions in Smalltalk. It's just
Yeah, yeah, to be
yeah,
pedantic, there are methods,
yeah,
but there are like first-class block, which are
yeah.
kind of like functions, except they run in the dynamic context of the object. So in that sense, they are actually more like methods.
Ah man, so we can't
I
do
don't know the
this.
details. I never actually messed around with Smalltalk.
So we cannot do this. That's pretty cringe. So we need to do like C.
It's gonna be like a monomorphic, a
Oh,
Poosman's version.
stop using, stop using words that Greg doesn't know. I don't know.
We're gonna have to do like a
Man,
Poosman's version of filter.
Greg doesn't know that. Greg doesn't know. Enumerator. NS enumerator. Enumerator. NS. Oh. ID.
Am I going crazy? There is a guy making flat map, reduce, filter, and map in Objective C. And
This
of course, I
guy's.
can't understand what the heck is going on, but apparently it works. Like, am I?
Oh, right. Say class. Da-da-da, da-da-da-da-da.
No, let's rename this.
No
Find to
void.
equal.
Oh, right.
Find equal, actually.
Found. I just want to see if it works. Just a sec. I'm trying to figure out the syntax on this nightmare.
On the fly.
Here.
Uh,
So we call. So
wait,
let's put a
what?
standard. By the way, the imports.
Man, what the
Uh,
fuck?
what?
I think it exists. I think this guy made it. I can't read it. I'm not. I don't have education to read this. But apparently it works. We can have the smallest set of FP, which is map, filter, reduce, and flat map. We need to change reduce to full just because of Python anyway. Okay, let me send you the link, Mageta. I'm not saying we need to use this now, but just something to keep in mind. I sent on the chat.
Not even gonna read, man. I don't know how to read. I am very comfortable writing this monstrosity here.
I can't believe this exists though.
I believe I'm writing this. I can't believe I suggested writing this.
And we had the motivation to make the flake work. Haha.
Ah, what about now? Undeclared function, blah blah blah. Because I changed the name without changing the definition. That makes sense. And it takes void, which is not the case anymore. Get out. Get out. Does it work? Thank you, brother.
Wow, so you can write it outside of the object. That's cool.
Yeah, but like C like, right?
Yeah, see, like for me, that's completely fine for what we're doing. Let's see if this works though.
Uh, okay, let me just see. Oh, to be more performant, if we care, although I don't have any hopes that this will be performant at all, can do it here inside.
Yeah, that's actually more performant. Yeah.
And then we pick this. It didn't end up not being that bad, I guess.
Push R, and then
So
you put in the push R.
here. Oh, let me
Well,
copy
actually,
the.
not. Yeah. So let me go back to the
Oh,
PDF.
wait. Should the R register?
Yeah, we need a try catch. We need a try catch because you're doing a pop.
Oh, right. Yes, sir. That is true. So this is different, right? It's not the same thing.
Maybe it's gonna
So
be a
let's
mix
see.
of both actually.
Let me put this back here.
Yeah, this whole deal with what to do if the stack is full or empty, that's kind of why Chuck Moore decided to go with circular stacks for his green erase chips.
In our defense, we don't not gonna have the problem of overflowing stacks because we have infinite memory anyway. At least for now.
Well,
If we
that
change,
doesn't eliminate the problem.
we
It
have
just
infinite
hides
memory
it
in this
very.
thing.
That just hides it very beautifully. Uh, okay, so we're gonna pop. Let me get out of here. We're gonna pop first. And then we check the value, right? Uh, actually, we don't need to check the value, right? We just
Yeah, not
write. Oh
anymore.
no, we
Not
do.
any.
We do. Yeah,
What?
because the stack otherwise it would blow. Okay,
Yeah, exactly.
so
Not anymore.
yeah, makes sense.
And
So
if
in this
we
case,
were able to pop. No, 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 no. Wait, wait, wait. There is something. No, that's right. That's right. Push data. It's not data stack. It's return stack on line 59.
return stack,
Yeah.
and then this disappears.
Oh, we need to rethrow the exception actually. Okay, this is push R. Pop R does exactly the same but swapping the stacks.
Does exactly the same, but swapping the stacks.
So where you see data stack, you're gonna put return stack, And where you see
So let
data
me.
stack.
Okay. So pop to R. We're gonna do.
What about instead of popping to R, we pop from R?
Nah, we can do that later. But the idea of the small talky thing is that you talk, right? So that's why it's small talk. So the names of the attributes they explain the actions you're doing, the
Sure.
messages.
No, I'm
Yes.
talking about
So
the
we
log.
can whatever. But this, I mean, we should do the correct names.
Yeah, no, that I
Uh,
understand.
okay. So this, right?
That's it.
And the
Now
okay.
we
Now
can
the
go
pop, the
to the
push.
ones that manipulate the data stack.
Wait a second. Did we do the pop A? We did.
We did
Is
pop
that
A,
right?
pop. We did four. Okay, now we need three more, which is dup, drop, and over.
The
Okay, actually the dup will be pretty very simple.
Dup
So
is
go
just
to
pick the value and
yeah, do a peek and do a
duplicate.
push.
Right?
The
Just
first
let me
question
do.
is, does the peek throw an exception?
Uh, it's gonna duplicate where? That's my
Top
question.
of the stack. Top.
Like it looks at the value currently on the top of the stack.
Yeah.
It copies the value and
Mm.
it
So it
pushes
just
it on.
pushes again the
Yeah.
next value,
Yeah,
right? So
yeah.
Yeah, but to see if we're gonna need a try catch or not, we need to see if the peek actually throws an exception
it does, I think. So let me do this. Dupe. So on the data stack,
on the data stack.
we pick
Peek,
and let's see.
it does. Nice.
Uh-huh. So stack is empty, cannot
Peek.
pick.
We probably copy pasted from the other one.
Yes. We definitely copy pasted. Uh okay, so we pick and then we don't need to do this BS. We just do
Data stack, push.
oh it's yeah. So data stack this and then push. Ta-da.
Yep, that's dup. Next one is drop, which is exactly the same thing,
So there's
but
two
instead of
more fingerprints.
yeah,
These two.
this is two more, drop and over.
Drop just
Pops.
is just a stack pop. Yeah, just
So drop is just to remove, I suppose.
Yeah, you just do a drop, a pop. Sorry, you just do a pop, and that's it. You don't even need to assign to something. You just pop.
Mhm.
That's it. And the last one is the
Uh,
over,
and the
which is the
over does
one that
what?
is kind of that. This for me, over is what like if you get used to this, you were just built different. I just don't understand. But let's go.
yeah. Over it looks at the value below the top of the stack, so there must be at least two items on the stack, and it pushes
Okay.
a copy of that value.
Yeah.
So it copies the bottom and puts on the top.
No, not the bottom.
Yeah,
Not the bottom. Let's
the
suppose that you have
second to
five
the top.
elements, and the
Yeah,
top is the number one. Over will
Right.
put a number two on top of the stack
So you have like one, two, three, and then you will pick two and put two. So it
on
will
the
be
top.
two, one, two,
Three.
yes,
three, four,
yes,
five.
Yeah, exactly.
that's correct.
I see. So it's like translating. Trans,
I
not
don't know how to
translating.
call
Oh,
that though.
translating. Translating. Yes, it is inverting the thing.
Yeah, it's inverting to some degree.
So, oh man, I how do we do this? Because
Yeah, that's the question. How do you do that? Okay, so
I
the
mean,
answer is
the naive way would be drop. Sorry, pop store, and then you just pick, and then you push the one you popped, and then
yes,
you push again.
exactly.
You can
But
do
you need to
that.
do
That
some
works.
checks. You gotta do some checks. For instance, the size of the stack needs to be at least two. And
I mean,
Yeah, I'm thinking.
if you
I
do
know
a
we shouldn't
pop
think of
and then
this.
peek, the check will be done implicitly, won't it?
wait, I didn't get it. Can you repeat, Mari?
Like if you do it the way Mageta suggested, if you pop, start a value, pick, and then push back the value and then push the value you picked,
Yeah.
Hmm.
the pop and the pick will do the check for you implicitly. You don't need to do an explicit check.
Oh, that's true.
Yeah, that's true.
Yeah, but then we're gonna have to change the exception being thrown
Oh
because
no, why?
because I think would be better for the programmer to know that the problem is because you're trying to do an over with a stack size less than 2, and peak will not tell you that.
All
But
right, it will just.
that's why we are rethrowing the exception. We just have to change the error
Yes,
message,
yes,
right?
yes. But that's what I meant.
Yeah. Mhm.
Uh,
Uh,
so let's do it. So you do a pop,
so pop
then a peak.
second,
Yeah. Then you
and then
push the top. No, yeah, yes, actually, you push the top,
pop,
and
and
then you
then we
push the
push.
second. The thing is, if ID is a pointer, are we fucked?
Why?
Because if line 89 is just grabbing another reference, we have two instances of a pointer pointing to a single thing, right?
I don't see why not. There are languages that pass things by reference.
Oh, it dereferenced on the stack anyway. Because if you recall, we remove it, right?
No, I'm talking about the peak.
Oh, the peak.
Yeah. Because if the
Oh, I
return of
see. We're copying the. Oh man, we should copy the value, not the
yeah, that's the thing.
memory. That makes sense. Because if we
No, what
manipulate
if
it, we might change
no?
both two positions at the same.
That's my
What if
fear.
your but what if your intent is actually to copy a pointer? Like, there's nothing intrinsically wrong about that.
No, I'm saying that in our case
Mhm.
it is intrinsically wrong because if you manipulate the top after the over, whatever you do to that value, you're gonna be changing two values at once because there are two places with the same pointer, right?
That's just how
Oh,
pointers work. I
yeah,
don't
but
see the
I think
problem.
Marinho has a point on like if it is a like we're thinking of numbers, right? Of
Yeah,
isolated things, but if it's like a memory address, which is what you would usually store, like a something there, because you don't push uh like a string, for example, to a register, right? You push a reference in memory for that.
yeah. But what I'm saying is that having two pointers pointing to the same thing being not the same thing, wouldn't that be a problem? Like, why
I don't think
would that
so.
be okay in
Oh,
our
it will
case?
be okay because it is naturally modifying the memory. Like
So
the
if you
usage
manipulate the
of
top
this
of the
should
stack,
already
we are
entail
fine if you're manipulating something different than the top of the stack.
because it is the position of memory that is the same. It's not because it's a element that is in the position of a stack that should matter. It's because it's the same memory.
Like, think of it this way, Lemos. A pointer is just a number that happens to be a valid
I
memory
understand that.
address.
I understand that. But as far as I
So
can
if it
tell, a
is
pointer is we are manipulating pointers just because of the language. This is not in the paper. The paper is, as far as I can tell, is talking about values.
no, but dude, if it is like this, like let's suppose it's like this and then that, right? The
Sure.
rest. The over will do this,
Yeah. Yeah.
right? Independent if we are doing this or any other thing, because it will be the same value.
No, no, no. But I understand that. But
But
I think that's the
what
Well,
you're
pro.
I
saying
think
is that we have top pointing here,
Yeah.
which is the logic of the code, right?
Yeah.
And then we have top pointing here too.
Yeah. Yeah.
So we should have like free this pointer here and just keep the value, which is the address only for this pointer and
well,
this thing.
Lemos, I think I see your mistake. You're talking about a pointer pointing into the data stack, right?
Yeah. Exactly.
But remember, the data stack, like if you want to be pedantic about following the paper, the data stack is actually implemented by registers. Registers do not have addresses.
No, no, no. I think we are getting confused here. Let me make myself clear.
Folks, I need to go now. Can I just push this?
Sure, I guess.
Sure.
Does it run?
I have no idea at all.
Okay, it doesn't. Awesome.
It doesn't run.
Uh, why it doesn't run? Attempting to push undefined. Okay, makes sense. I'm trying to push something that doesn't exist. Then.
That's fair.
No, no, but halt doesn't exist.
It does.
How does
It just
halt?
does nothing.
Ah,
Oh,
okay.
return. Just
Okay, why
stop.
pushing A didn't work though?
Because it don't
Oh,
have
we don't have the
anything.
hardware. That makes sense.
Yes. So I
Okay,
just push
so let me
this.
explain for you, Marinho. We are messing with pointers because of the language, okay? Because when you do a pop in Objective-C using mutable arrays, you don't actually get the value. You always get a pointer to the value. So we need to pay attention. What exactly do we want to push into to the abstract stacks? When I say that, I'm talking about the stacks in the paper. I believe that paper is talking about pushing values, right? Which you can say the values are just bytes in a register. Yes, there is, but there is we can't mix the implementation, the operational semantics with the notational semantics. You see, so I'm suggesting us to pay attention to this because of Objective C stuff. Because
Right,
IDs are
because
basically pointers in the language level.
Yeah, I understood what I meant.
Okay.
I mean, you
Just
can just cast them to integers. That should work, right?
Well, I mean, sure, but the thing is that uh, this is so fucking cursed. The fact that these IDs going around are basically void stars, functionally speaking, and and
But we're
they
actually, but they're actually just integers in disguise. They pretend to be void stars, but they are actually integers.
yeah, but they are addresses. That's the fucking crazy part. We couldn't make, at least maybe it's just ignorance in our part, but we couldn't see anybody in the internet doing differently. We couldn't make a stack that only works on opcodes. We had to use IDs for some random freaking reason.
It's because Objective-C is based on Smalltalk, and Smalltalk is dynamically typed.
Yeah, I saw some very scarce. Oh, you have to go, right, Magetta? So thank you for today.
yes, sir. I
Thank you,
will
Magetta.
paste
It was
here.
fun.
So there's the pull request.
Okay, thank you. I'm gonna try
If
to
you need me,
test.
just ping me. I'll probably play around with this, and I'll try to read the paper. So see you
Okay,
guys.
see ya.
Bye.
Let's
See ya.
finish the recording by this with this discussion, Mario. Anyway, so
Okay.
there are some. I found some posts talking about like typed stacks on Objective C, but they were doing something that we were not interested in. It was not what we wanted, etc. So we had to use IDs. And okay, it's because it's a dynamic language. Fine. The problem is that we need to pay attention of what the fuck we are pushing, because if we push a number that happens to not be the number that we want, but a memory address to what we want, we don't want to push the garbage. We don't want to push that random generated hash memory address. We want to actually push the value that this thing is pointing to. So that is why I warned, I said what I said before about is if this is a pointer, we are fucked because we need to dereference that because we don't want to push the memory address to the stack.
But but if the value that the pointer points to is not actually integer size, then what do we do?
No, but in this case it is. In this case it is
Why?
not because of the anything Objective C is forbidding is checking for us, but because we know that only going to be we know what we're going to be pushing. We're going to be pushing integers all the time only. So there is no verification. You could push whatever you may decide, an address of anything you may decide. I mean, like you may push an address of an integer 64, an int 64, and then I think that doesn't fit in an S
Wait,
number.
you're talking about are you talking about pushing using boxed integers inside the stack?
When you say boxed integers, what do you mean?
I mean, instead of putting the actual integer that we're interested in the stack, we put a pointer to an integer. Like that's
Yeah,
a common thing.
that's kind of my
That's a
understanding.
common that's a common thing in dynamic languages when we're doing like arbitrary precision math. Because like if you push a number that's 128 bits or whatever, it doesn't fit in, it's larger than a reference, which is what dynamic languages usually operate on.
Yeah, but my understanding is that we are actually pushing references to the stack. That's what we are doing.
Oh yes, but we would probably operate on integers that happen to be the same size as references, and those are, I'm pretty sure they are actually just unboxed integers, like actual primitive values, and you don't. I mean, it's Objective C. There's obviously access to C level stuff, so you
Yeah,
know.
yeah, but do you agree, given that we are only pushing and popping pointers, do you agree that if we push the same pointer twice, we have one pointer talking about two places in the stack?
You're talking about a pointer that points into the stack, are you?
No, there is a pointer in the stack. This
Okay,
pointer points to a number in whatever. It can be whatever in the memory region. It can be whatever.
okay,
What we are doing there, we are grabbing one pointer and pushing it again. So the same pointer, right? The same pointer.
yes,
So my question is, now we have the same pointer located in two different places in the stack. If
yes.
we manipulate this pointer somehow to do stuff, would this interfere with the other place that this guy is being duplicated?
If you do, yeah, if you dereference the pointer and you manipulate the memory that it points into, then yes, because the two pointers point to the same region in memory.
Yeah. So that was my
But that's
fear.
but that's just normal aliasing. It happens whenever you have a pointer to a mutable thing.
No, I understand that. I understand, but that's my immutable bias screaming at me, saying this is a pointer, and you are duplicating
Lemos,
that and putting the two
Lemos,
things.
we're implementing a virtual machine that has mutable memory and pointers into mutable memory.
No, I understand that the
So
nature of this involves mutability. I'm fine with that. But I would suggest for us to keep the mutability as restrictive and as controlled as possible. So in that particular case there of the over, my first instinct would be to clone the thing, to dereference the pointer, and then make another reference to that same value. But
but
I'm asking,
that's not how hardware works, man.
but we are on software, man. What do you
But
mean?
we are but we are implementing a virtual machine. And we're basing ourselves on a paper that describes actual hardware. So
No, I understand that. I understand. So you were telling me that there's no problem in having the pointers in multiple places.
there isn't. And in
Okay.
fact, uh, and in fact, that's actually how functional languages work. Actually, like because we know that we will never mutate the values that we are pointing to. There's no problem with sharing pointers, right? So that's just a thing that happens. It's just sharing pointers is more dangerous when there's mutability involved. But that's just the nature of mutability. It has nothing to do with aliasing pointers.
Well, if there isn't a problem on having the pointers, that's weird to me. Maybe that's because maybe I'm not very used to um, this sort of stuff.
Like, let me write an example real quick. Like, this is plain scheme, not actually racket. Okay. So if you do define A to be cons of A and B, and then you do define B should be A, and then you do set star of A to LOL, and then you display B. What do you think is gonna happen? Like I posted the code in the chat if
Yeah,
you
yeah,
wanna
I'm
show
reading
it.
it. I'm reading it. Um, what do I think is gonna happen?
Yes,
I would expect, I would expect to B to not change.
but it will because in scheme, not brackets, in scheme, pairs are mutable by default.
No, no, but I understand that. But I don't know how this is related to what we were talking before.
That's literally the same operation. You know how I
Oh no,
defined
no,
B
it
to
is the
be
same
A?
operation. Sorry, sorry. Now I got it. That is the same operation that we are potentially doing with the thing there. If we manipulate the pointer, we're not even doing that yet. We are just doing an over, right? So we're not doing anything. But my question would be, after an over, if I manipulate the pointer of the top, would the second guy, like second from the top, would that guy change as well?
Like if by manipulates a pointer you mean mutate the thing it points into, then yes. But if by manipulates a pointer you mean treat the pointer as a number and do some operations on it,
I
then the
don't mean
answer
the
is
second. I mean the first.
yes, it will. It will.
Okay, so the next question would be, will that happen in this stack-based VM?
Probably it happens on most low-level code. We're implementing a VM. There will be low-level code running on it. Then so yes.
Then the question is that a problem?
I mean, languages work, right? And they do this all the time, so I don't see why not.
I never read low-level code that deep, so I don't know if they actually just allow that. That sounds to me like a problem. Like I'm gonna be honest. If you tell you
Why why do you think I bailed on Python when I was trying to learn my first programming language? It's because of stuff like this. It took a while to get my head around it.
what do you mean by stuff like this? Because they actually do that?
Aliasing. Yes, aliasing. Like it's really confusing if you're not used to it. And you're not because you're used to immutable code, right?
Yeah,
Your functions
that's my
and all
thing.
that.
So I think that we're gonna discover that pretty shortly just by testing. And but my first instinct would be to just uh, change that over implementation that might get pushed and just do some sort of a clone in that reference.
No, man. That's not. Then you are
No,
making
not
it
clone the reference.
impossible.
Clone the dereference value, right?
Eh, that there are two problems there. First of all, you are assuming we can just allocate memory willy-nilly. We can't actually because this is a machine language that we're implementing. The programmer is supposed to be in full control. We can't just allocate memory behind his back. The second problem is you're making it impossible to implement mutable objects on top of your machine.
Um,
Actually, there's a third problem, which is you're presuming that there is a data model. There isn't at this level.
no, I'm not presuming a data model. I'm presuming that an over operation does not give you control of the second from the top element based on the top. That's the only assumption
Dude,
that I'm making there. Uh, the first
no,
problem,
you are actually assuming a data model because you said, what if we make it a clone instead of a pointer copy, right?
yeah, a
But in
clone of
order
the
to,
dereference value. That would be a pointer again.
but no, the problem is this. In order to clone a value, you have to know its actual structure so you can replicate it.
No, but that's easy. It's just a matter of cloning a register, in the case of the stack, for instance.
Oh, you're talking about. But there shouldn't be pointers to registers because, as I said,
Again,
registers don't actually.
no, again, we need to do a separation, or maybe it's a naming thing. Every single time I'm talking about pointers, I'm talking about this Objective C limitation. The fact that we can only manipulate IDs. We can't manipulate things. We can only manipulate pointers to the things. My concern is an Objective C concern.
We can just cast them to integers and be done with it.
Sure, that works. Uh, but we didn't. Magetta pushed the thing pushing IDs.
But that's just the thing. The idea is just how the bits are going to be interpreted. They don't actually change the actual bit pattern. So that's fine.
No, I think we are confused again. Maybe I am now confused. My main thing is, let's
Like if you if
suppose.
like let me put it this way. If you take a pointer and you cast it to an integer, at runtime that's actually a no-op. This is a type system level operation. It's not an actual machine operation.
Yeah, but we're not talking about the machine. We are talking about the tool that we are using to develop the machine. That's what we're talking about. We need to make clear the separation between operational semantics and the notational semantics. Everything related to the machine model, the registers, the diagrams, the table, the instructions, all of that is denotational. What I am
Fine,
talking
let's
about is operational, which means talking about Objective C problems.
okay, so let me make it very clear. If you have an Objective-C ID, which is just a reference, right? It's a
Yeah,
pointer,
yeah.
and you do an Objective-C level typecast from an ID to an integer, that's a no-op because that's a type level operation. There's no runtime operation that you do. You're just literally reinterpreting the bits to mean something else.
Oh, if that's what Objective C is doing, then I lost my argument. I don't know how they do it. I just know that we can cast it. I actually don't know what it does behind the hood. I have no, I
It
have
does the same.
completely zero idea.
It does the same thing that C does because it has to interoperate with C, and C does that.
Sure. Um so we did some casting already before in the else if. I think you saw it. So we had to do
Yeah,
some sort of casting there. But if it's just changing the the interpretation, it's not actually changing the data, it's just the same amount of bits all around, then there shouldn't be a problem, right? There
there
shouldn't be a
shouldn't be.
problem if they are doing just that.
Of course,
Uh,
this doesn't. This, if we do it this way, there is actually a small problem there because now we're saying that the word size of the machine we're implementing is the same as the word size of the machine that's running the
yes,
program.
yes, we are saying that. We are saying that. But for I think that going like polishing bits to get more performance or less memory consumption, following the paper more strictly. I think that's just gonna be a pain, because you're gonna have to use masks and crap and stuff like that. And I don't even know if doing the masks on the level of the operational semantics would be enough because the zeros will still be there. We can mask all we want, but we can only manipulate a byte. That's the lowest level that we can go as far as I can tell.
Yeah, actually, the virtual machine can't manipulate bytes. It can only manipulate words, 32-bit words. Oh,
Yeah,
I
yeah,
guess
yeah,
in our case,
yeah.
they would be 32 or 64, depending on what machine we're actually running on. But
Yeah, I agree. I understand. But if in the implementation level it's gonna be easier to do something related to the 32 bits by doing 8-bit manipulations, we can't because this is C. At the end of the day, so C you can manipulate on the bit level. So if we have, for instance, I don't know, the three last bits on a word of the machine mean something different than whatever. We're gonna have to do some masks and stuff like that in the machine that we are implementing the other machine, right? And we can
yeah,
because it's very easy. But I don't want to push this right now of trying to follow more strictly the memory consumption thing because it's gonna be just this is gonna remove a bunch of the fun because now we're gonna have to think, wait, this is X amount of bits, so which mask is this crap? I already did this exercise because I did computer engineering. So I did already this mental exercise of thinking which mask I need to use because the three last bits of this byte or this word, whatever, means something different, and I have to filter those. I have to shift, and then all the shenanigans that goes into microcontroller programming. I already did that, and I don't think that's gonna be
That's
fun.
that's why I like Zig. Zig actually automates a lot of that stuff.
Exactly. When you told me that you can have an arbitrary amount of bits to make your integer, that's awesome because it's just such a pain. Uh, because of performance concerns, people break the 8-bit usual name coin byte. They break that model to fit operational flags or LED flags, LCD flags on this bit and that one. And if both of them are both one, it means something different as well, and so on and so forth. So I want to skip that just for the sake of simplicity and to try to maintain the fun. Um, but we are right in the sense that if we really want to be like um, consuming the less amount of memory, following the 5 bits opcode of the paper.
That's just the thing. The 5 bits of opcode thing. The way that the machine in the paper actually does it is the opcode is 5 bits, but then each word is 32 bits,
So
right?
they waste a bunch of bits basically.
No, actually they cram 7 opcodes per word.
Ah, okay. So a single cycle does 7 instructions.
No, a single fetch fetches 7 instructions, and then each cycle will execute a chunk of the word, like an actual single
No,
opcode.
but if these registers are 32, you are still wasting bits.
Yeah, you're
Like,
wasting 2 bits actually.
no, wait. What do you mean by 2 bits? If you have, um,
Like the machine in the paper is 32 bits wide, the word,
sure,
okay?
sure,
The opcode is 5 bits, right?
sure.
Which means if you cram 6 opcodes into a word, you're using 30 bits and there's 2 left over.
Yeah, but you got.
You could, you could, if you want, allow the 2 last bits to be used to refer to a restricted set of opcodes, in which case you could cram as many as 7 operations per word. But the paper doesn't actually do that because it's a bit more complicated.
Yeah, but when you put like the program counter and all of that into the opcodes, aren't you wasting even more bits when you do that? Because you're gonna do one opcode per cycle, you said, right?
No, 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 no. The program counter points into a word, not an actual opcode, okay? And then when it's time to fetch the instruction, what happens is you fetch the entire word and you put it in an instruction cache. Basically, it's a 30-bit wide register of 5-bit segments, basically just breaking the word into opcodes.
Mm-hmm.
And then you don't fetch the next word until you actually executed all 5 opcodes. But the program counter actually doesn't count opcodes, it counts words only.
But how does it do that? So when a program counter
That's the
receives
thing.
it receives a
That's
word,
the
so it
thing.
receives from 6 to 6 instructions.
It receives up to 6 instructions at once, yes. And then that's the thing. You no longer need to fetch any more instructions until the 6 are done.
But how does it know how to separate them? Does it use a mask or something and clone and keep cloning? How does that work?
No, it actually the register, the instruction cache register is actually a shift register. So it maxes out the first 5 bits and executes that, and it shifts over the next instruction
Ah,
and
okay. So
executes that.
another guy does the shifting. Okay.
Yeah, and
Okay.
then when you shift everything, the next instruction is a zero, and
Yeah.
conveniently in this architecture, zero means fetch the next instruction word.
Oh, that's kind of clever then. Okay, now I understand. Okay, so that's okay. That's okay. So that's how they do it. So they keep it in a word size, but they have an internal mechanism to keep working on five based opcodes. I see.
5 bits opcode, yes,
5 bits,
yes,
sorry. I see, I see, I see. Okay, so the next thing that I would like you to think about before next Tuesday
yes.
is, do we actually need to convert the stack to be register based? Both
Uh, I
stacks.
mean, I mean,
Like
I
what
mean,
are the limitations in terms of features, in terms of whatever that we're
I
gonna
mean,
have to?
technically, technically, the current implementation is fine. Like, I actually looked at it while Magetta was editing the stack code. The current stack implementation is array-based, right?
Yeah,
So that works just fine, actually, because if you think about it, an array of you know values
sure.
is really just there's not really that much of a difference. It's just there's a level of indirection there that we could get rid of, but in
I
Objective
agree.
C, I don't think it's worth the effort.
No, we are already gonna suffer from the with the performance. That's fine. But I'm talking about features, right? So for instance, if there
Yeah,
is some feature that does some interaction between specific registers in the stack,
there isn't. The only registers that matter are the top two.
then we are fine, I think. Then we can just you can say it's Nutella and I'm fine with that. You can just say if you go to the real professional way, you're gonna just do it with registers all the time. And I would say yes, but it's just so much more convenient, and we are not losing any features. Uh, so I would like to maintain that because as we did the session today, I was just pleased by the fact that man, the fa- the stack is already there. It just works. Like it just makes sense. I don't want because when I think about redoing it, I'm gonna have to redo two things. I'm gonna have to redo the stack, and I'm gonna have to redo the probably potentially, potentially, right? If I manage to make the functions with the same type signature, I wouldn't have to change my get what we did today.
Yeah.
But I don't know that.
Yeah. Yeah, for style, actually, I can't really just do an abstract stack for the interpreter that I have in mind because um, because I don't want to shuffle data around needlessly, which will happen if I do a plain old rug brain stack. I have to do something a bit more clever than that, unfortunately.
Wait, what you said you're gonna suffer from if you do an abstract stack? You said shuffling data around.
Yes, because you see, for Sal, there's no limits to the number of values you can have floating around at the same time, right?
Sure.
But actually, for the sake of, not having a giant thing that has to be kept loaded on the actual
Oh, you're thinking about
low-level call stack,
performance. Ah,
yes.
okay.
And also to deal with the fact that any finite stack will eventually overflow, I'm thinking of implementing some kind of automatic overflow, like some mechanism that automatically spills the stack if it grows too large.
That makes sense.
But
That makes
then I
sense.
don't want to have to like consolidate the values all at the bottom of the stack of the hardware level stack, not hardware level, the interpreter level, the actual stack that I keep in the structure, right, in the context. Like there's a spill register which points to a list, which uh, is actually more like a closure vector. But anyways, um, and that's where the data that overflows, in the case the stack grows too large, goes into. But I don't want to have to move around the values in the stack after I do that, you see?
Ah,
So
if you do a move, you would have a hard time doing a bunch of extra moves, right?
yeah, in order to avoid that, my plan is to implement the stack as a ring buffer. And then after I spill the stack onto this extra list, I just move the bottom of the ring buffer.
Yeah, I think I understand. Maybe it's actually good to transform the current abstract stack into a ring buffer as well. I don't know if I know ring
Yeah,
buffers very
that
well.
actually that actually depends on what you wanna do on in case of an underflow or an overflow. If you wanna do something special on that, definitely go with the ring buffer. Otherwise, the current implementation is fine.
But I gotta be honest, right now, if you have an underflow, that's just an exception.
Yes.
If you're trying to manipulate the stack and stuff. And right now we don't really have an overflow, although I want to introduce that notion because I think it's just like I understand like this is basically Zosing arguments all the time. Hardware is cheap. You can have a bunch of
Uh,
memory nowadays. But I
yeah,
think it would be
I
more
do.
fair for hardware simulation to have kind of like a ceiling.
Yeah,
So
there is like if you wanna use a reference for that, the green erase chips, if I'm not mistaken, they have a maximum stack depth of. Let me look it up actually, just to make sure I'm not giving you incorrect information. Green arrays, actually it's colorfork.net or .io actually. Colorfork.github.io. I think it's here or here. The status, features, rationale, source, uh, instruction set.
let's try to finish this because I
It's
really gotta go. Not that the conversation is boring, but I'm afraid I'm not gonna be able to sleep today.
okay. Uh, yeah, I don't remember how many values can fit in the stack. I'm pretty sure it's more than 8 though, which is what Magetta currently has. And like most Forth implementations that I know about usually have at least 16 values that you can fit on the stack. So Magetta setting the default to 8 is definitely on the low side.
Mageta's doing what, sorry?
Like the stack that is currently implemented in Chime, right? It's
Mm-hmm.
set to 8 values, right? Currently.
No. We changed that. Right? Remember?
Oh, right.
Right. No, we are talking about the
Opcode.
stack, right? The stack doesn't have a limit right now.
It doesn't?
It doesn't have a limit.
Okay.
Let me just double check this to see if I'm going completely crazy. Yeah, it doesn't have a limit at all. You can have, but that's the thing. We can add a validation to the push that will check it based on the current size of the stack. If you can push and if you can't, we're gonna just throw an exception. That's an okay behavior. We just
Okay.
didn't do that because, again, hardware is cheap and you can have terabytes of RAM. So it's actually like impractical to imagine a stack going on overflow. Because who the hell has a program that needs terabytes to be loaded at the same time? Um, but I think it's a valid requirement to have that because things get just too cheap when you just add no ceiling, right? You know, because when you have no ceiling, you can just do the most inefficient thing ever, and it's gonna work. It doesn't matter how much more memory you're consuming because you have the memory.
Yeah,
So it's basically the infinite problem. When you have infinite resources, you don't care about them.
indeed.
So
Indeed.
I'm thinking about adding that as a. Actually, if you want, you can create an issue on the repo, and I would
Uh,
I
limit,
would change the
limit
code
the stack size. Yeah. Okay.
to add a stack size, and I would have to add in that check in the push, and I would also add the try catch when we're using push in the code. Um, so that's the thing that we can do, and I think that's like you can say like um, we are cutting some corners. We're not doing the most outstanding implementation of the thing, but I think it's reasonable. We are the trade-offs, the things that we are trading off, is just because we're not losing features, and we are trying to follow a reasonable amount of the paper. So we did stack manipulations today.
Yeah.
So I think
There's one thing
it's
yeah, there's about that, just a final comment. There's one thing I dislike about the opcodes of the architecture in the paper. The fact that the primitive copy operation is over instead of dupe. Oh, actually, it is dupe. Not the primitive shuffling operation is over instead of swap. Actually, is what I meant to say. It bothers me because in my mind, swap is simpler because it only does one thing: is it reorders the stack. Over does two different things. It reorders the stack, but it also copies a value. Like,
I understand what you're saying, but here's the devil's advocate take on it. A swap is doing two moves. It's moving values from one place to another, and I believe that doing a copy and an addition is simpler than doing moves. You may say this is a Rust bias, and I would say yes.
It is a Rust bias.
But moves are moves, man. Moves are Turing complete. You know that. So moves are moves.
Actually, the thing about moves is that like they take the same theoretically they can just take no extra space. If you try to implement swap in terms of over, you will use extra space no matter what.
No. But that's not uh, talking about simplicity. That's talking about performance slash memory
It is about,
constraints.
yeah, that's an observation about the simplicity thing. Like you have a stack of values, right? What
You
can you do with
yeah.
the stack? You can use the values from the top, obviously. Uh, but in order to manipulate the stack and actually do useful things, you have to be able to reorder things. That's one thing. You have to be able to copy things, and you have to be able to hide things. Which hiding and reordering, they become the same thing in a statically iterated language, but machine languages for a stack machines aren't. So they have to be two separate things. You can implement hiding by moving things into the return stack. You can implement reordering with swap, and you can implement copying with dupe. And they are three instructions that each do, well, technically four, because you have to be able to unhide things. So you have four instructions, and each does conceptually one thing. But then you have over, which
No, but if you use
both.
those arguments, I can argue the same thing. It does two things, but I can conceptually view as one thing.
The problem with over is that if you stick to the stack discipline strictly, like only operate on values that are on the top of the stack, it only get extra values if you actually need them. Over is actually taking one value that it doesn't do anything with, which is the top value, and then it's copying the value below that, right?
Sure.
You can actually, I don't want to get into reductions of implementations because, as you said, they are equally expressive, but like it just bothers me that you're doing reordering and copying in one operation.
No,
I
I
don't know, man. That
understand that.
bothers me for
I
some reason.
understand that. No, I totally understand that. But what I'm trying to say is that as you are bothering by reordering and copying, I am bothered by two moves. And you can say that the quantity is the same. It's true, right? That's fine. But for me, I have, especially
Actually, it's
knowing
not
that the
even.
move instruction x86 is too incomplete, I want to be careful with moves. I want to
But
have the
moves,
least amount of
but
moves.
but moves in a stack machine are actually less expressive than moves in x86.
Aren't you moving values from one piece of hardware to another?
Yes, but you are limited in how you can move because of the stack discipline.
No, I agree that you are limited on how you can move, but it is still a move. It is still changing things from hardware pieces to hardware pieces. I understand that having a discipline may decrease the chances of doing crap, of doing explosions. I
Let me
understand.
put it this way. If you only have the data in the return stack, let's ignore the A register for the moment. If you have the return stack manipulation and you have dupe, but you have no swap and no over, you can never reorder anything at all.
Yeah. Wait. Which operations do I have?
You have to and from R, and you have swap, and that's it.
I don't have push.
push from A to A. No, no A register, just to and from R, and then and
Well, if you don't
and
have
dupe, I
push, I
guess.
agree. No, because I was about to say that if I have push, I actually don't need swap and over to do reordering. I can just clear the stack and do push in the other order.
You're still thinking in terms of a stack that you're still thinking in terms of like being able to access memory, right? As a thing. Obviously, the machine has to do that to be useful. But I'm just talking about pure stack manipulation. Like you have the data in the return stack, and you can move things between them. That's it.
No, but that's the thing. Can't I? Oh, okay. No, you said it. You said it right. I'm thinking that I have memory, but if you don't, yes, you can't. You can't do that. Okay, yeah, I never thought about that.
And then if you want to be able to copy things, you can add dupe, but then you still can't reorder anything, right?
Yeah, you can't reorder yet. Yeah.
And then if you add swap, then you gain ability to reorder things arbitrarily because between hiding things on the return stack and swap, you can fish for arbitrarily deep values. But without swap, you cannot actually reorder anything at all, even if you have dupe.
Yeah. Yeah, I agree with that. And I think that even though I am more afraid of moves, and if I remove my hat of devil's advocate and just say what I think I would be it would be more convenient to me to use, I would probably get swap over because over is just confusing to me. I don't have intuition about stack-based languages, so for me over is just like wow. Every single time Zozin said, "Oh, we can just do an over and a dup and this is done," I was, "What are you talking about?"
Yeah,
So,
if it
yeah,
helps, you can think of over as being to R, dupe, then from R and swap.
yeah, yeah. I understand that you can separate over into other instructions.
But that's just the
Anyway,
thing. Yeah, it's basically four operations if you're doing just pure stack manipulation, which I don't know, man.
no, I understand. I'm not. I don't have a horse in this race at all. I'm gonna learn and probably maybe get a horse doing chime. So for me, it's fine. Uh, uh, so for me, just interested. I was just interested to know what would be the your take on it. Anyway, I'm gonna finish the recording now.